Hello and welcome to today's video. In today's video I'm going to be showing you how to use Cinemachine and Unity's new input system to make a top-down twin stick shooter. This uses the WASD keys and the mouse, or if we swap over to a controller, so I'm on my controller now, use the left stick to move around and the right stick to aim. If we're just stop still, see with the mouse, this is back on the mouse, if I move over here it kind of snaps automatically, like it does rotate around but it does it very fast. The right stick here on the controller, if I'm pushing left now then I suddenly press right, you see that we rotate through that, the whole position, it doesn't just snap, and I think that just makes for a bit of a nicer kind of feel to the control scheme. So yeah, with that said, let's just jump straight into it. Okay, so here I am within Unity, and I've just got some packages installed already. This is just a blank 3D project. It's not a URP project or anything, it's just the built-in 3D renderer. And I've got Cinemachine installed, Pro Builder installed, and the Unity input system. So just make sure you come up to your package manager, and just make sure that Cinemachine, the input system, and Pro Builder are installed. Pro Builder is not a necessity, but I'm going to be using it just now. So the first thing I'm going to do is I'm just going to make a new sort of plane here, 20 by 20. And this is with Pro Builder. And I'm going to select our plane, I'm going to center its pivot, and then I can just close this and center that out in the middle. And I'm just going to swap over to my preferred editor layout. Okay, so I'm just going to right click and create an object. I'm going to make a capsule. I'll just call this our player. And I'm just going to set this to 000, and then I'll hold down Control and just snap that up one unit. So that's now sat there. And then I'm going to right click, 3D object, add in a cylinder. I'm just going to rotate this way 90 degrees. And then I'm just going to shrink this down. And this is just going to be some eyes on our capsule here, just so we can see that we're facing the right way. Control D, duplicate them. I'm going to right click here and make a material. I'll just call this black. Make it a dark black. Reduce the smoothness and then drop this on the eyes. And then I'm going to duplicate this. I will rename this to blue, or whatever color you want it to be. Make it a nice blue, and I'll drop that on our bean here. So this is just so we can see the direction that our capsule's facing. What you may want to do, and what you need to make sure, is that the eyes are on the side that's pointing where the blue arrow is, so they're facing forward on our bean. And then I'm just going to set up our camera. So for now, let's just zero out our camera, and I'm going to go up to Cinemachine, create a virtual camera, and I will press F2 and call this the player cam. And I'm just going to drag our player into the follow target, drag it into the look at target. Under body, it's going to be transposer. In binding mode, I'm going to select world space. And for aim, I'm going to choose hard look at. Then I'm just going to move our camera into sort of the top-down position that we want. So there, for example. And I'm going to turn off X damping. And yeah, we'll just leave that there for now. Okay, so let's just make a folder here called materials. Drag these in, and then I'm going to right-click, create a folder, and call this scripts. I'm going to come in here, I'm going to right-click, create C# script, and I'm going to call this twin stick movement. And let's just open up this script. We've got our script here, and we're going to be controlling our player through the character controller. So I'm going to do requires component type of character controller up here. So when we drag this onto our player, it'll automatically add that. And I'm just going to make some space up here, and I'm going to do a couple of serialized field private floats. And I'm going to do the first one is our player speed, which is how fast our player is going to go. I'm going to do a float gravity value, and this is going to equal negative 9.81 f. This is going to equal 5f. Just going to press Control D to duplicate that line. We're going to have our controller dead zone. And just set this to equal to 0.1f. And then I'm going to set this to 1000. And this is going to be our rotate smoothing. Actually, this is going to be called the Gamepad Rotate smoothing. And then we're going to want a. You don't need to keep this serialized, but I'm going to keep it serialized just so I can see it in the inspector easier and I don't have to keep printing out to the console. And we're just going to keep track of our current control method is a gamepad or not. And then we need to get a reference to our character controller, which I can just call controller. And then in the awake function, we'll do controller equals get component type of character controller. And we're going to need some private vector 2s to keep control of our input. So we'll have a private vector 2 movement and a private vector 2 of aim. We need a private vector 3 of our player velocity. And that'll do for now. Now we need to just jump back to Unity, and I'm going to right click, create, and choose input actions. I'm just going to call this player controls. And we'll just open up our player controls here. Now I'm going to add 2 control schemes. I'm going to add one is controller, which is going to use our gamepad. And I'm going to add a control scheme called KeyBM, which is keyboard and mouse. And we'll add in our keyboard, and we'll add in the mouse. And I'm going to choose all control schemes up here just so we can see that. And I'm going to do call this action map controls. We'll have this action is movement, and this can be type pass through, and it's going to be affected too. I'm just going to duplicate that and rename this to aim. So for our binding, our first binding here, we're going to do the gamepad and the left stick, and then we'll do the gamepad and the right stick. Then I'm going to, under movement, I'm going to add a 2D vector composite, and we can call this WASD. And then up's going to be the W key, down's the S key, left is the A key, and D is right. And then under our aim, I'm going to add a binding, and this is going to be the position of our mouse. This is the screen position of the mouse. So with our right stick gamepad, I'm going to select controller as the control scheme, and position is keyboard and mouse. All of these are keyboard and mouse. And our left stick is the controller. So I'm just going to save that and close this down. I'm going to select it in the project browser, and I'm going to come up here where it says generate C# class. I'm going to check that and click apply. And that's generated this player control script here, which we can access in our twin stick script here. So I'm going to do a private player controls called player controls. And if you want to learn out much more about the input system, I really recommend a YouTuber called Samyam. I'll put her link in the description below, but she does a lot of really good videos covering everything you could think of with the input system. So yeah, I'll link to that below. I highly recommend her channel to go watch that. So as long as our player controls, we need a private player input called player input. And I'm going to duplicate this line up here and say player input. And then we need to do using Unity engine dot input system for those to work. So in the awake function, we've got our controller. We can also say player controls equals new player controls, and player input equals get component, and this will be our player input component. And because we're making some player controls here, in our onEnable function, we need to enable them. So player controls.enable. And in our onDisable function, we need to do player controls.disable. And we can get rid of our start method because we're using awake. And then in our update method, to keep this organized, I'm going to have 3 methods called handle input, handle movement, and handle rotation. And we'll make these down here, so we'll have a void handle input, void handle movement, and void handle rotation. So in our handle input script, we're going to do movement equals player controls dot controls dot controls dot movement dot read value vector 2. So player controls is the name of our asset. So we've got player controls is the name of our input action. The action map is called controls, and the action name is movement. So in your script here, you've got player controls movement. If you named your action map something different, you'd change that here. If you named this like move instead of movement, you'd type move here. And then the vector 2, and the vector 2 is this is the control type. So that's where that naming sort of comes from in the script. And we're just going to do the exact same thing here with aim. So we'll do aim equals player controls dot controls dot aim, and this is also a value, a vector 2. So we'll do read value vector 2. So we've got our input coming in here. So now we can move our character. I'm going to do vector 3 move. I'm going to set this equal to a new vector 3, and we'll do movement dot x in the x. We'll do 0 on the y, and movement dot z dot y in our z of this vector 3. So as we push up on the stick or WASD, we're going to read this into a vector 3 called move. And then with the character controller in Unity, we can just do controller.move, and then we can pass in where we want to move and the time dot delta time times with our player speed. So where we want to move and how fast we want to move there. And then just so if we do get hit up in the air or anything, this isn't going to cover jumping. You don't always jump in twin stick shooters, so this isn't going to cover jumping. But if you do end up in the air, like if you fall off a level, you'll want to fall down. So we can do player velocity.y plus our gravity value times with time dot delta time. And then we want to, at the end of this movement update, we just want to do controller dot move, and we want to fall down. The logic here for this movement script comes from the Unity documentation, character controller.move. A lot of this stuff's from here, but changed so it works with the input system. So yeah, if you just Google for character controller.move, if you want to learn how to jump, you can do that here, where you add stuff to the velocity on the Y before applying it. But I've just used these 2 lines to make the character fall down. So that's going to handle our movement. So let's just make sure this is all hooked up and working. If we go back to Unity, we've got our player here, and if we drag in our twin stick shooter script onto our player, you can see that's added the character controller, it's added the player input, which here we can choose our player controls, and we've got our twin stick movement script. So let's just hit play. And now using WASD, we're moving around, and if we use the left stick on a control pad, we will also move around there. So now we need to use our mouse or the right stick on the controller to actually rotate and like look where we want to go. So the first thing we want to do is we need to figure out whether we are using a gamepad or a control or the mouse and keyboard, because that's, if we're using the control pad, the rotation's different than if we are using a mouse. We have to do 2 different things to sort out the turning. So the first thing we need to do is do a public void on device change, and this is going to take in a player input, and I'll just call this PI for now. And our is gamepad bool that we made earlier, we can do is gamepad is equal to pi.current control scheme dot equals gamepad. If it does equal gamepad, then our is gamepad is true, and if it doesn't equal gamepad, our gamepad bool is false. So if we go back to Unity, I'll just show you this working. So I grab a controller and turn that on. Got our player input here, and we want auto switch to be on. I'm going to change behavior here to invoke Unity events, and I'm going to expand events. And we've got our controls changed event here, which passes through player input. We can just hit the plus here, drag in our twin stick movement script, come down to twin stick movement and do our on device change here. So if we hit play now, you can see here control scheme is keyboard and mouse. So if I'm using the keyboard here to move around, and then if I press the left stick on the controller, we can see that swaps to controller over in that right hand corner under debug. And because that says controller, we put equals to gamepad. We want it to check whether it's called controller. That's because in our control schemes, I named it controller. So what I'm going to do is I'm going to select our controller, edit controller, and I'll just rename that to gamepad so it matches our device. Save our asset. And what you do, if you do for some reason want your control scheme to be called something else, or if you're detecting whether it's keyboard and mouse, you need to reflect that here, but I want it to be gamepad, so I've changed it within Unity here. I've renamed it to gamepad. So make sure that's saved. It should recompile once we click back into our project. And we'll try that again. So we select our player. Over on the right hand side, you can see control scheme, keyboard and mouse, but we want it to be gamepad. And then you can see that our gamepad bool here becomes true when we're using the stick, and it's false when we're using WASD. And this is really good here, so you can fire off an event, for example, that your UI can subscribe to. So when you swap control schemes, you could the UI buttons could change from like showing keyboard keys to Xbox controller keys or vice versa. Okay, so that's working there. So now we need to handle our rotation. The first one I'll do is our gamepad rotation. So we can do if is gamepad is true, then we need to rotate our player. So I'm just going to copy and paste the stuff in. I'm going to copy and paste the code in here and then walk through it. So here we've got a controller dead zone, and you can see that's 0.1f, which we've set up here. And we're going to take the absolute value of our aim.x. So with the left stick, it can be on the x-axis. It could go from -1 to +1. Taking the absolute value, it just means that we don't have to care about the sign before it. So we don't have to do negative aim.x is less than negative controller dead zone, and then make it like you'd end up having a really long if statement. So we just take the absolute value of aim.x. So if it's -1, it'll be 1, and if it's 1, it'll still be 1. It just basically drops the negative sign. If that's greater than our controller dead zone, or the y is greater than our controller dead zone, then we're going to make a vector 3 called player direction, and our right vector is going to be times by our aim.x, and then we're going to add to that vector 3.forward times by aim.y. And then if the player direction dot square magnitude is greater than 0.0f, so if we've changed and we're moving, then we're going to make a new rotation, and it's going to be quaternion.look rotation, and we're going to look in the direction that we are wanting to point with our stick here. And we're going to rotate around the up vector, and then we're just going to set our rotation. You can either set this directly to the new rotation if you want it instant, or if you want a slow kind of like pan, so the character has to actually like turn around itself. It doesn't just snap automatically. you do quaternion.rotate towards transform.rotation, so our current rotation to our new rotation, and then we've got our gamepad rotate smooth in here. You've got to set it to 1000 to make it fast, I've found. It's just a good value that I found. You may want to tweak it more. So that should just work. So if we go back to our twin stick shooter, if we go back to Unity and hit play, so you can see here, while we're walking around, I'm using the mouse, we're not looking. But if I use the right stick on the controller, can you see what I mean about you have to rotate all the way around the axis? So I'm pressing right now. If I press left on the stick, I don't automatically just snap to face in that way like you do with the mouse. I just feel this feels better on a controller because then you're a bit more direct. You're directly controlling it with the stick. And it feels a bit more sort of, I don't know, a bit more natural. If you wanted it to snap directly, then like I said, you'd get rid of, you just set the rotation to the new rotation and that should do that. Or you could even make the gamepad rotate smooth in just even faster. So it still goes through it, but just a lot quicker. But I found 1000 is quite a nice, like a nice turn-in speed. So that's our gamepad handled. And then down here we can do else. So if we're not using our gamepad, then we're going to need to shoot a ray through our camera to our mouse position to see where exactly we're aiming in the world. So we could do ray equals camera dot main dot screen point to ray, and then we'll pass in our aim vector, which is our, in this case, it'd be our mouse position. It wouldn't be the sort of vector from the stick. And then we want to make a new plane, and we'll call this the ground plane. And we'll set this equal to a new plane, which is orientated upwards, so the normal is pointing up. And we will just do vector3 dot 0, and we'll do float ray distance, and we'll do if ground plane dot raycast with our ray. We're going to pass in our ray, and we're going to pass out how far away, the distance to that point on our plane. And then we're going to get the point from where our, we're going to get the point where our ray hits this plane. So ray.getPoint. Pass in our ray distance. And then we're going to look at the point, which is going to be a new function we're going to make now. So we'll do private void look at, and this is going to take in a vector3 called lookPoint. And now because this point could be kind of on any Y level, it causes some crazy kind of rotation. So if you hit like a box, for example, the character would tip to look upwards at the box. You want the character to not rotate to look up. So we just need to correct the point. So we're going to do a vector3 height corrected point. And we're going to look at the positions X and the look points Z. But we're going to use our Y position as the Y of this. And then we're going to do transform.lookAt height corrected point. I did get this from a forum. I can't remember exactly where it was because this is from an old project. So if this doesn't make sense to you, it's me not explaining it very well because it's one of those where I know how it works, but it's hard to explain how it works. It's kind of beyond the scope of the video, but you can just copy and paste this, and then it works. I know that's not the most exciting kind of explanation if you wanted to learn more. If you did want to learn more about it, the Unity documentation is the best place to do that. So, for example, if you want to learn more about the plane that we're using, you can do that here. This explains all about it. Same with the rays and the ray casting and the screen point array. If you just look for that on the Unity documentation, you'll kind of figure out exactly what this is all doing here. Okay, so with that said and done, if we go back to Unity and hit play, so we've got our mouse and we're now looking towards where our mouse is hitting. And we are looking on our controller where we want to look with the right stick. And again, we've got our WASD and we can move our mouse and look directly where our mouse is. Swap over to the controller and it works exactly the same way. So that's it for this video. I hope that was useful. Like I said, if anything didn't make sense, you can either leave a comment below or go to the Unity documentation and kind of read up more about it there. The project files for this will be available on my Patreon, which is linked in the description below. If you want to just download the project and get started with it that way, you can do. But in the meantime, thanks for watching and I'll catch you in the next one. Bye!